Okay, good morning, Cisco cohort. Out of respect for everybody's time, I'm going to go ahead and start. We'll cover today's material. This is the last chapter of the Routing and Switching Essentials course. So let's just look at what's going to happen here for the next 2 weeks. So today I'm going to cover the Chapter 10 material and show in Packet Tracer the Cisco Discovery Protocol and link layer discovery protocol, how that works. The lab that I had originally intended for Wednesday, I'm probably going to change that to another lab. I don't like the layout of that lab. It's really confusing. It's not really clear. You're supposed to use 2 routers, one representing a cloud. So I think I've got another lab there that's real clear as to the connections between the routers and the switches. I'm going to probably put that in there later today so that when you guys come in Wednesday, you'll be able to do that. So Wednesday morning, I'm going to bring up, we'll have a short 6 session. I'll bring up the lab and show you how to get started with that, with the Cisco Discovery Protocol and link layer discovery protocol. This is a real easy lab, just shows some show commands. Okay, what's happening then next week? Next week is the last week of classes. A week from today on Monday, May the 4th, is going to be a work day. I always try to build in a work day in the last week of the semester, so you can catch up and do any labs and chapter exams and so forth. Remember, you have 50% of your grade comes from your 10 chapter exams, and the final exam, the average of those 11. All open book, they're all open book, even the final. And then the other 50% of your grade comes from the, I think it was 10 laboratories that we ended up having in this particular semester. So there'll be no 6 session, there'll be no Blackboard Collaborate session on Monday. That'll be open time for you to do that stuff. I have activated the practice final exam. It's active now. And the practice exam is not graded in any way. It doesn't matter whether you take it or not. But if you want to kind of get an advanced look at the character and the feel of what the final exam will be, the real final exam, it'll be a small portion of your grade. You can look at that. And in this RSE course, there is a trick you can do on the practice final exam. You can go into the practice final exam and answer one question, or really answer no questions at all, and tell it to grade it. And it's going to complain that you haven't answered all the questions. And you'll say, well, go ahead and grade it anyway, submit it anyway. And then you can go back and click on something. Don't click on course feedback. That's useless. Click on the one that says item feedback. And then you'll see all the questions and all the correct answers for that practice final exam. And you can use it as a sort of a study guide for the routing and switching essentials portion for the CSET test. Please also take the opportunity sometime before a week from Wednesday, which is our scheduled time for our real final exam, to take the course feedback form. Now, this is not the same form I asked you guys to complete on WebAdvisor. The WebAdvisor student satisfaction survey, that's entirely optional. We ask that you do take that so TCC can gather statistics on student satisfaction. But the Cisco Networking Academy absolutely does require that you take what they call the course feedback form. That's in the Network Academy Assignments tab, where you have all your exams and the final exam. You're going to see something that says course feedback form. Got to take it, because if you don't take that, you will not be able to take the final exam. So there's got a business rule that you must complete the course feedback form. It's kind of like the other student satisfaction survey and WebAdvisor. It just asks you some questions about how you think the Networking Academy is preparing you for, getting a job and learning about networking and things of that nature. And like the WebAdvisor evaluation, I can't see anybody's individual answers. I can't track anybody down and do retribution against them because they gave me a bad review or anything like that. So I just get to see composite results. Okay, so a week from Wednesday will be our actual written final exam. The skills exam, the skills lab exam that we normally have when we're in the classroom, we're not having that this semester. So it's just going to be 50% of your grade for the 10 laboratories, and the other 50% of your grade will be the 10 chapter exams. And the final exam, add up to 11, divide by 11, that'll be your average for that 50% of the grade. If we were still in the classroom, you would come in on Wednesday, May the 6th at 9:30 a.m., and we're required to give you like 1 hour and 45 minutes by Texas state law to take the test. So you can come in. I'll probably actually turn it on closer to about 9 a.m. on Wednesday morning, and you can take that exam really anytime you want in the next 24 hours after that point. You won't be constrained by the 2 hour and and a half hour, 2.5 hour block that they schedule their rooms for, you can take it anytime that day. So if you want to sleep in that day and take it later in the day, that would be fine. Just try to complete it sometime in that day, because the day after, Thursday, May the 7th, at about 9 a.m., I'm going to close books and submit the grade. So that's going to be the final deadline for doing your final exam and doing any of your 10 other regular chapter exams and submitting any of your laboratory Microsoft Word documents to me to be graded and put into the course. Hang loose 1 second. I'm just checking if people have logged in for attendance here. One, two, three, four, five, six, seven, eight, nine. 1, 2. Missing somebody. Who am I missing here? Oh, I see. Didn't put you down yet. And I didn't put you down yet. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I've got everybody that's logged in. Okay, good. Okay, so we're going to launch into this PowerPoint slideshow for Chapter 10. And I'm just going to do the first couple of slides, and then I'm going to go over to Packet Tracer and give a demonstration of the Cisco Discovery Protocol and Link Layer Discovery Protocol steps. So let me see. I should be able to click share now. And I made a little ding noise. Did somebody else log in? Okay, that's good. So everybody should be able to see the first slide here. My microphone is active. Everybody should be able to hear me. So we're going to talk about device discovery, management, and maintenance. And the next screen is exactly like the first one. Okay, so we're going to look at device discovery. First, he's talking about Cisco Discovery Protocol and Link Layer Discovery Protocol, which are two things that allow us to see what our neighbor devices are. A Cisco Discovery Protocol is proprietary to Cisco, only works between Cisco devices. But there's an open standard equivalent called Link Layer Discovery Protocol that works with, it's an open system, so everybody can use that. Then we'll look at device management, network time protocol, which is a thing that keeps all the routers and switches and servers clocks all in sync. So when we go through the log files, after an intruder is broken into our network, we can match up as he steps through the network and see what he did first and see what he did next. And then last, we'll look at device management. We'll talk a little bit about the iOS files, how you back up files and restore files and things of that nature. Okay, so first up, device discovery. So this is the classic Cisco Discovery Protocol, and Cisco has always supported this because it's their proprietary protocol. So what this is a thing that if you have two directly attached devices, like he has at the bottom of the screen, there's a graphic for a router and a switch. I'm going to show something like this in Packet Tracer in just a second. So the thing about Cisco Discovery Protocol and Cisco devices is it's on by default. And if you don't want it, you have to turn it off. You can turn it off for the whole device, or you can turn it off on an interface by interface basis. It's very useful within our corporate network, within our enterprise network, because we can, like, for example, check that the particular wire of the G00 interface of the router is indeed connected to the F01 interface of the switch and confirm our wire. And the neat thing about it is it works at the data link layer. So you don't have to configure any IP addresses at all for this to work. All you have to do is do a no shutdown. On a router, you have to do a no shutdown on the router port. On switches, of course, switch ports don't need no shutdown required. They simply come up and up as soon as you plug a wire in. So if, for example, I was at that router and I was at the console port and I wanted to check to see who is my directly connected switch, I would simply go to the router prompt and type show CDP neighbors, and he would show me my neighboring device. In this case, he would show me the switch. He would tell me the host name of the switch. He would tell me what plug on my router is going to which port on his switch. That's good to know. He could even tell me the version of the iOS that's running on that switch. And if I've configured a management address switch, like an IP address, it would tell me that. So now I know an address to try to telnet into if I want to branch over to that device. If you type the command show CDP interface, you get even more detailed information about the connection. Now, the Cisco Discovery Protocol is on by default on all Cisco devices. In other words, the default command is CDP run. It's running by default. If you don't want it running on the entire device, you can type the command CDP run, and it'll turn it off. Now, what if you wanted to leave it running from within your enterprise, within your company, but you wanted to disable it on the port that goes to your internet service provider? Because you don't want people from the internet coming in and mapping out your routers and switches and figure out which iOS versions they are, because they could be a vulnerability with your iOS that you have on the old device, and they could try to use that to break in. We definitely want it running within the enterprise. For example, all the Cisco IP telephone sets, they need Cisco Discovery Protocol to figure out what port of the switch they're plugged into and what phone number they should be and all the other telephone parameters that should be there. For example, what's their voice VLAN? What's the PC desktop's untagged native style VLAN that he's going to get? So we need that running from within the enterprise. So we could leave it running within our enterprise, but maybe that serial port like S000 that goes to the outside world, we could put it on that with no CDP enable at the config-if for the S00 port. We could disable that. So it tells us a lot of stuff. Under this section, discovery devices using Cisco Discovery Protocol, it tells us the device identifier, the host name of that router. It tells us the ports, the local and the remote port. That's very useful for checking wiring. It tells us what is this remote device. In the case of the router, it would tell me that that remote device over on the right, it was a switch. And it would tell me the platform of the device. For example, it would tell me that the switch is a Cisco 2960 switch. And then I could do show CDP neighbor detail and learn the iOS version and the IP address and things of that nature. Now, the only problem with Cisco Discovery Protocol is it only works on Cisco devices. It's proprietary to Cisco. There are some other Cisco proprietary protocols like IGRP, routing protocol, that don't run on other devices. This is normally not a problem within a company or enterprise because they're going to buy all the same brand of equipment. They're not going to buy half Cisco routers and Juniper routers and mix them up. They're going to use all the same make and model as much as they can get away with, so that all their technicians are familiar with the Cisco iOS and the Cisco hardware. But other devices like Microsoft computers and servers, things of that nature, there was a open source equivalent of Cisco Discovery Protocol. So if you think of EIGRP as a Cisco proprietary routing protocol, and think of OSPF, Open Shortest Path First, as an open standard routing protocol, and anybody can put those in their routers because there's no licensing required. Link Layer Discovery Protocol is like Cisco Discovery Protocol in the sense that Spanish is like Portuguese, but they're kind of slightly different from each other. They both convey information. So Link Layer Discovery Protocol is an open standard, which means that if you go into your Microsoft computer and you go into the network control panel and it tells you you're connected to your cable modem and it tells you you're connected to the internet service provider, that's using Link Layer Discovery Protocol. So if we had a mixture of, let's say we had Cisco routers and Dell switches, just to give an example. Link Layer Discovery Protocol works on both of these. And so you could still get the same type of thing you had if you were just had all Cisco devices. So it has the same sort of features. It's a layer 2 data link layer discovery protocol, very similar to Cisco Discovery Protocol. All you have to do is make sure the ports are activated, and in most switches, the ports come up automatically. On Cisco routers, you have to do the shutdown on the router port to bring it come up. So I can show LLDP neighbor, and it'll show me very similar information to show Cisco Discovery Protocol neighbor. We're going to see that in just a second. LLDP run. Now, here's the difference. Cisco Discovery Protocol is on by default Cisco devices. Link Layer Discovery Protocol actually wasn't present until recently in Cisco devices. They relied upon their proprietary device, but Cisco's done a pretty good job of embracing open source stuff like Open Shortest Path First. And Link Layer Discovery Protocol has been available for a few years now on Cisco devices. So on some of the old switches that we used to have in the lab, it wasn't in there. We couldn't do this lab. But we got new equipment like 2 years ago, and it supports all this stuff. So if I want Link Layer Discovery Protocol to be running on the device, like the Cisco router or switch, I can say LLDP run at the configuration prompt. If I don't want it, I say no LLDP run. So the difference is Cisco Discovery Protocol is on by default. link layer discovery protocol is off by default. You can turn it on if you want it on. And you can also turn it on individual interfaces. You can turn it off and on the individual interfaces. So most phones can, if you have voice over IP telephones, they mostly work on both Cisco Discovery Protocol or link layer discovery protocol. You're going to need one of these running in your enterprise if you're running voice over IP desktop telephone sets. So if I want to discover my devices using Cisco Discovery Protocol, I would say show CDP neighbor. If I'm using link layer discovery protocol, I would show LLDP neighbor. Okay, so I'm going to stop this and I'm going to share the packet tracer. Where's my packet tracer? Okay, packet tracer should be visible. 1, 2, 3, 4, 5, 6, 7, 8, 9, just checking attendance. And I'm going to put a simple topology on the screen here. So I'm going to go and click on the network devices, and I'll choose this router and put it up on the screen. And I'm going to go ahead and go into the configuration mode. Oh, he's still booting up. Give him a chance to boot up here. Fortunately, these packet tracer devices boot up a lot faster than their rare ones take about 3 minutes. He boots up in about 10 seconds. Any second now, that sucker is going to be up. I'll be able to show you what's going on. Okay. So I'm going to go into the configuration mode, and I'll just call them R1. And this automatically issues the command hostname R1 for me. Now I'm going to have to go back into CLI and okay, here I'm in the CLI, and I need to do the no shutdown. If we do it, do show IP interface brief, we can see that we have 2 gigabit ports on this switch. I'm going to run one on this router. I'm going to run the 0 port to one switch. I'll call it S1, and I'll run the 001 port to the second switch, and I'll call it S2. But while I'm still here, I'm going to go ahead and do a no shutdown on these. I don't need to assign any IP addresses. I'm just using plain old Cisco Discovery Protocol and then link layer discovery protocol. So I'm going to do a hot interface, interface range, gigabit 0/0/0 through 1, and no shutdown on both those ports. That should work. So now if I do show IP interface brief, they're going to be up. They want to be up, and the reason they're up and down at this moment is I have not yet plugged any wires in. A port can't come up and up unless there's a wire plugged into it. So let's go ahead and do that. Let's see if I can minimize this. And let's bring in some switches, and I'll just bring in a couple of plain old switches and configure and connect them. So I'll go and connect them first because the switches require 30 to 50 seconds to do the spanning tree protocol scan, and they won't come up until that's over. So I'll go ahead and make a connection. So I'm going to make the connection between the G00 port on the router to the first switch, and I'll use port 1 for the first switch. And I'll make a connection between the G001 port on the router to the second switch. I'll make it port 2 because I want to show the difference between those when we do show CDP neighbor. And then we can wait for those to time out. And while that's happening, I'm going to go to the switch, and all I'm going to do is give it a host name, just because it's got a unique host name instead of the default host name of the switch. S1. S1, automatically does a command for me. All I need to do on that switch, go to the second switch, we'll make it S2, host name, and punch it in. Okay. All the lights have turned green. It just takes a few seconds for that to take place. Okay. So now let's see, I'm going to be able to go to the console prompt here, and I think I should be able to just restore this. Okay, good. Good, you can see that on the screen. I'm at the console now of R1. Okay, so here we are at R1, and let's see, if I type the command show IP interface brief, everything's up. Oh, good. No IP addresses have been assigned here. But no shutdown is layer 1. Layer 2, the first up is the physical layer. The second up is the protocol or data link layer. So he's up and up. So has enough time elapsed here? Should I be able to see something? Show CDP neighbor. And look at that. I've got the timer here is about 60 seconds. I just changed the host name less than 60 seconds ago. So I've got the old default host names of switch and switch. So let's look at the second entries. I gave them meaningful host names. I gave them S1 and S2. So let's see if I move the mouse here to the scene. Okay, so we look at S1. My router G00 port is connected to switch 1's port F01. That's good news. That's good information to have. My router port G001 is connected to that switch port F0/2. What kind of switch is it? It's a Cisco 2960. What capability is that platform? S for switch. Okay, so that's great information that we can find out there. Now let's go to the other end. Let's look at the switch back at the router, and I want to point out a peculiarity about Cisco Discovery Protocol. I'm going to go to S2. And I'll go to the CLI. So here we're at S2. Now remember that it's directly I didn't emphasize this. Directly connected neighbors only. So S2 is directly connected to R1, and then he relays through R1 to get S1. So when I type show CDP neighbor on S2, all I see is R1. Why don't I see S1? Well, he's not directly connected to me. He's directly connected to R1, and then everything has to relay through R1 between the two switches. So S2 only sees the directly connected neighbor, but I still see that my local port number 2 is connected to router R1 through R1's G001 port. And what is the capability of that neighbor device? I'm at the switch route now, not the router. The capability of that device is a router, and it's ISR 4300, which is the product family that we have there. So this is great information, and if we show CDP neighbor detail, we get even more information. Now, this is the part that's dangerous information that you would not want to reveal to, say, the people on the internet. So on that wire that leaves the wiring of your routers and switches in your enterprise that goes to the internet, you probably want to turn off CDP on that port only. And you can do that. You can leave CDP running within the enterprise, just disable it on that one single interface that leaves the enterprise. Because I can see here, I can see the iOS version. I can see, I haven't applied an IP address to this device yet, but if there was an IP address applied to it, I could see that address. And so someone could try to telnet or try to break into that device using some vulnerability that that particular version of the iOS might have. So this is a lot of useful information for our authorized people within the company, but it's really bad information that you would want hackers from the outside world to be able to get to. Okay, now I'm going to go back to the router. Did I pull the router away? Yeah, I need to do another click on the router. Drag it into place here. Now, let's see, has enough time elapsed here? Okay, now I type show CDP neighbor, and you notice that those two switches, their default name was switch, they're gone. They timed out. It says 60 seconds. Every 60 seconds, the CDP packet gets transmitted. So they're gone. Okay, now we're here. This is what he's seeing, the current host names of the switches. Now, LLDP is not on by default. I'm going to go to configuration mode and type LLDP run. And I have to do that. Oh, I have to do that to the switches too because they're not on by default. Oh my goodness, I better do that on both of those. So config T, LLDP run, that switch. And I'm already in the config mode, LDP run on that one. Now let's go back to our router, float router. And let's see what we got here. So I'm going to do a show CDP neighbor just for comparison. I'll do a show LLDP neighbor. Oh, I mispronounced it. Show LLDP. They only do what you tell them to, not what you want them to. So look, the reports are very similar. They both show you the local interface on the router. They both show you the remote ports that are on the remote device. They both show you this is switch. Well, yeah, he's calling it a bridge, and we used to call switches bridges before they got promoted to be switches. But look at the extra stuff that LLDP is telling us. Oh, if I got a cable on them, it'll tell me that. If I've got a a wireless LAN access point, it'll tell me that stuff. So it tells us a lot of information, very similar type of information. So that's the difference between link layer discovery protocol and Cisco discovery protocol. And the lab, I think I'm going to recopy this other lab instead in place of this confusing lab that I have listed right now. And they're going to have you do these type of things. There is a gotcha, show CDP traffic. That command is not implemented in Packet Tracer. Okay, good. Now I can stop with this and go back to sharing the file. Share now. And let's see, it's going to allow me to. Okay, the bug in the software, I got to go through this again. Okay, now we're going to talk about traffic management. I'm sorry, I meant time management, not traffic management. Okay, let's see, someone popped in here. Okay, let's say that a hacker, wait a minute, we're not supposed to call them hackers anymore, it makes them feel bad. Oh yeah, we're supposed to call them malicious intruders. No, that's bad now. We can't call them malicious because that makes them feel bad too. Threat actors. Now we're supposed to call them threat actors. Has come into our system, and somebody clicked on, somebody in the company received an email, and they clicked on a link within the email that they shouldn't have clicked on because they hadn't been properly trained yet on bad links and ransomware. And this guy wants to come into the system and break into it and do stuff. He's going to come into this employee's PC. He's going to jump to the switch and the router, and then he's going to jump to the server that's got all the goodies that he's trying to steal. He wants to encrypt all the files on the server and hold them for ransom. As he jumps through these various systems, it's going to create log files on the switch and on the router and on the servers as he jumps through them. And if the clocks are not in sync on all these devices, it's kind of hard to tell how did he stair-step it through our system, because the incident response team, the security people, are going to try to track, how did he get in here? Where was his point of entry? And then how did he stair-step through the routers and switches and to the server farm so he can start using that stuff? So if the clocks aren't in sync with each other, the log files won't match, and we can't tell, well, did he go here first? Did he go there first? So what we want to do is create a reference clock within our company. And this shows 2 of them, Stratum 1 servers, 2 of them. Let me say it this way. If you only have 1 clock as a master clock, how can you be sure it's right? If you have 2 clocks and they disagree with each other, which one is right? So you should have 3 clocks, at least 3 clocks, maybe more. If you have 3 clocks and one of them's wrong, well, the other 2 are right. So the idea here is all of the devices are going to look to some reference time within our company, within our enterprise, and they're going to use that as the master clock to set all the devices. So I'm going to maybe set one of our, in this diagram at the bottom of the page, they've gone to one of these places on the internet where you can get a reference time, like for the National Bureau of Standards or time.windows.com, and you can use that as your reference time for what time it is. And then you can go, in this case, the router R1 in the middle of the bottom diagram, that's going to be the NTP server for the whole company. And all the other devices are going to be NTP clients that look to that server for a reference clock. So all the log files are going to be in sync and in time with each other. So we can either manually configure the date and time, because these routers have a battery backup clock in them, similar to a desktop PC. But a better choice would be configure network time protocol. That way everybody's clocks are exactly the same. So NTP is this hierarchical system of sources. Stratum 0 are the authoritative time sources that the government maintains on the internet. And then the stratum number indicates how far the server is from the time source. So the National Bureau of Standards is level 0. That's the highest hierarchy. And then we can set up preferably 3 servers at our company. If we're a large company, our stratum 1. And then they'll radiate down to our server farm. There'll be stratum 2. and that'll radiate down to our employee desktops and PCs, and now everybody is in sync with each other. So to configure this on this diagram at the bottom of the page, you would go to R1 and set him to be the NTP server. And then you could go all to the other devices and type NTP server, whatever the IP address of that R1 is, and they'll all say, well, instead of using my battery backup clock, I'm going to go to R1. He's been identified as the NTP server. I'm going to get whatever his time is. If he's only battery backup, well, at least we're all on the same time. If he's getting a stratum 0 from the internet, well, we'll have a very accurate time. And then you can type the command show NTP associations and see all the devices that are associating each other to share the time. You can type show NTP status to see how long it takes for your client workstation to establish. It does take about 2 minutes. When you type the command STP server 1.1.1.1, where that's R1's IP address, it takes about 2 minutes to lock the clocks. So you can type show NTP status, and after a couple minutes, you'll see, oh, I'm locked into it. You can also type show clock, and before you lock into the server, it'll say, I'm getting my time from the built-in battery. And after it changes, show clock will say, oh, I'm getting it from the NTP server. So now, this is great. All our log files are going to be in sync with each other, and if we have an intruder come in and mess with our system, we at least can follow him through and try to prevent future things like this from reoccurring. Now, all those log files that were generating, the intruder came in and he created log files in the routers and the switches and the servers. And so think of when you go to a router or switch and you type no shutdown, and a second later a thing pops up on the screen that says the port's coming up and up now. And it appears on the screen, and then it vanishes off the top of the screen when you do your, you press the enter key, it eventually vanishes off the top of the screen. Okay. So what a Syslog server is, I can set up any cheap Intel desktop machine and put a Syslog server on him, and he will receive all the duplicate entries into the log files that appear on the screens of these devices and then vanish. It'll be copied onto that hard disk drive on that Syslog server. So on the diagram at the top of this page on the right-hand side, all the stuff that appears on the router screen and vanishes and appears on the switch screen and vanishes, it's also a carbon copy of it is sent over the wire, the network connection, to the Syslog server, and he has them all. So you can go to the Syslog server and you can see all the log files for all the devices, and you can view the security incident guide. You can see all this stuff and try to line it up to where you can perform a security analysis and figure out how he hopscotched his way through the system. So supported by most networking devices. Normally we don't capture log files from desktop employee PCs, but we do want to definitely capture it from switches, routers, servers, things of that nature. Now the severity level is how much garbage do I want? Do I want warts and all, everything in the world, even debug messages? Do I want a lower level, just more crucial messages? So this severity level from 0 is only the worst type of thing. The router had to restart and it put a message, I'm crashing, I have to reboot. Down to level 7, which is everything in the world. So there's 8 levels here you can choose from to identify how much detailed information do you want to go into that hard drive on that Syslog server. Well, gosh, hard disk drives are so cheap now, I want pretty much everything. Okay, at the bottom, a very important thing. This is usually on by default on routers and switches on Cisco devices. If not, what this command service timestamps log date time does is every time a line is printed into the log file, it adds the correct date and time, which you have ensured are correct because you had a network time protocol NTP server going. And that way now when you look at the log files, you can match up the date and time from S1 and the date and the time from R1 and the date and the time from the server they tried to break into to see what's going on there. Okay, so that's Syslog operation. So it's going to take the output and put it into columns. Of course, we want to turn on timestamps. And then we can, network administrators, security researchers, security incident people can look at this large amount of data and match the date and timelines and figure out what's going on. By default, all log messages are sent to the console. So like when you type no shutdown and the log message pops up on the console, that it went up and up. You could type show logging and see this on the screen. On the routers and the switches, we need to define what is that logging server, that inexpensive Intel desktop machine that I want to set up to receive all the messages. Here's my logging server. So I need to put in the logging IP address of that device. I need to define the chap level. I might need to do logging source interface to point to the Ethernet interface that points to that device. And then I'll turn on logging and start doing it. Then if we go into command show logging, we can verify the configuration we've done on that device. Okay, device management. Show file systems shows us all the file systems available on a device. The ones we're mainly interested in is the flash memory, where the iOS operating system file is located, and the NVRAM. Now, if we plug in a USB drive and back up to that USB drive, we mount that USB drive, we can show it, it'll be mounted. So show file systems list all available file systems. The dir command, like the dir command in the command prompt for Windows, it lists everything that's in the flash drive. PWD, print working directory, is a command that verifies what subdirectory you're at this point. Like in the Windows system, it always shows you what subdirectory you're at. In the Linux type system, which the guys that wrote the iOS or old Linux, Unix guys, you have to type PWD to show what directory you're at. When it changes the directory, CD will change the directory. So if you want to say back up your text file, back up your startup configuration file, what you can do is go into TerraTerm or Hyperterminal and turn on the facility which captures everything to a notepad file, and then do show run, and it'll capture everything to that notepad file, and now you got a backup of your configuration file that you can use later. Okay, I want to back up my configuration to a TFTP file server, which is a file server on the network that's a trivial file transfer protocol. It's kind of like FTP file transfer protocol, but it's kind of stripped down, no names and passwords, stuck with one directory. So we can create a TFTP server and put a large hard drive in there. And if I type that first command, copy running config TFTP, it's going to take the current running configuration of this router. Looks just like our 1941 router in the lab. And it's going to copy it to the TFTP server. Now, after you type enter, it's going to say, well, can you tell me the IP address of the TFTP server? And can you tell me what you want that host name of that running configuration to be, the file name? And it comes up with a default for you. And then it's running configuration text files are very short. It'll only take a second to do this. Okay, now let's say I want to copy back to a USB drive. So USB ports are present on most Cisco devices. Ours have two. They're outlined in orange there on the bottom right-hand corner of the graphic. So what we can do is type show file systems to make sure it's usually called USB flash 0 or USB flash 1. You can type a directory of it, and then you can copy the running configuration to that USB flash drive and very quickly back it up to a USB drive. You can even copy, back up the iOS itself. You can copy flash USB. It'll take a few seconds longer, but it'll copy to there. Password recovery. Cisco publishes the password recovery for every device they make on their website, which sounds dangerous, but the only way you can perform password recovery on a Cisco device is you have to be touching it. I cannot telnet to a device and perform password recovery over the internet. So we have to have, there's physical security and there's technical security. Technical security is the passwords and secure shell for encryption. Physical security is we lock our servers and our devices in a safe area with a card key or something where only authorized people can get to them. So here's a scenario that's very common in the business. The system administrator leaves the company and no one else knows what the password is, and now we got to add a new user to reset somebody's password. And it's a Microsoft Server 2016 running Active Directory domain services, and no one knows what the Active Directory administrator password is. Well, if I can be in the room with that server and touching it, yeah, I can boot up a USB drive and recover the password. I can change the password to something I know. I really don't care what the original password is. I just want to set it to something that I know. So same thing with routers and switches. On a Cisco router, if we can be up close to the device, but we don't know the login password, we don't know the enable secret password, there's a procedure where we can go into the device, and if I'm up close and personal and touching it, I can turn it off and on again, and then I've got 60 seconds to issue a special break character from my TerraTerm. And then I can tell the router to boot up in a mode where it doesn't need the passwords anymore. Think of you A+ guys, safe mode for Windows machines. I can boot into the safe mode if I have a problem, and I won't ask me any passwords. You have to hold down the F5 key within a couple seconds when the machine starts booting up. In some machines, it's the F8 key. Some things you have to hold down the Shift or Control key, and you can boot up your Windows into a disaster recovery mode where you can fix stuff that's messed up with it. So I'm going to boot up the router into what's called the ROM monitor mode or Ramen mode, and I'm going to change the configuration register. Normally it's 2102. That means boot up normally, and after the iOS boots up, load the configuration, the startup configuration file, which has the passwords in it. I don't know. I don't want it to do that. So if I change the configuration register to 2142 and then reboot the router, it'll boot up normally, but it will not load the startup configuration file. It'll act as if it doesn't exist. It's still there. You boot up the router and it'll ask you that question, do you want to go into the initial setup dialog? And you'll say no, and you'll go to the privileged exec mode with no password required because it thinks there's no passwords. And then you can simply copy the startup configuration back into memory. You're already at the privileged exec mode. You don't care that you didn't know the password. And then you can simply reset the password. Go to the configuration mode, say enable secret class, you reset the password. There's a couple of gotchas. If there's any interfaces on the router, they're in the shutdown mode. You need to do the shutdown command. But this is a quick and easy procedure that you can do on a production router during the business day. You can do this in less than 5 minutes. And there'll be a few minutes of disconnect while the router boots up. And then it'll be booted back up again with a known password, and you resave the new password, resave your running configuration, copy, run, start, and then you fix the router. And business note, if you ever go out and do a password recovery procedure, you must charge at least $300 to do this. And always carry a notebook in your hand, and let's work on our verbal skills for consultants. Anytime you walk into a customer site, you have the notebook in your hand, and they show you what's going on, and always say this, this is bad, and really terrify them so that when you bill them later, they aren't so mad at you. Okay, on to iOS system files. The iOS 15 system files were very simplified. In the old days with the 12 and 11, we had dozens of different, what we called feature sets. So ISP would want feature sets that supported lawful intercept. The old doctor's offices and lawyers' offices want a feature set that supported novel network. So you could get dozens of different feature sets that corresponded to what you needed to do that you'd buy from Cisco, varying according to what the features were. So when they switched to version 15.0 of the iOS, they went from 12 to 15. They skipped 13 because that was unlucky. And they skipped 14 because in some Oriental countries, 14 is kind of like our 13. They think it's unlucky. So there's a universal image, and then you can add, it's called IP base. The routers come with IP base. So our routers come with IP base. And then if you want to add a data farm technology, you add that onto it. If you want to add unified communication for Cisco phones, you add that. If you want to add security, you add that. So when I bought our routers in the room, I specified the security set to go on with it, in case we ever want to teach CCNP security or something. So our routers have the IP base plus the security set. All the Cisco Academy labs will work fine with just plain old IP base. And so these are activated through a licensing process. It's like the old Novell servers where you'd put in a licensed floppy disk and add 50 users to it. Okay, now let's, I started to mention this earlier. We're going to use a TFTP server to back up our iOS image and back up our configuration files like a running config or a startup config. So here's the steps to back up the iOS image to a TFTP server. First of all, you have to plug the server into the system. And you want to make sure that you can access that TFTP server from the console prompt of the router, ping the IP address of the TFTP server. Make sure there's sufficient disk space on the server because you're going to back up this iOS file that may be like 100 meg. And then type that command, copy, flash, TFTP, press the enter key, and he will ask you, well, what's the IP address of the server you want to copy it to? Verify the name you want it to be stored on that TFTP server, and then it'll copy it right over. Okay, now I want to copy the iOS image back to a device. Let's say there's a new version of the iOS. I want to put it on my router to get a new feature or a bug fix or security fix. So I go from the TFTP server, which is probably a Windows machine, and I go to the internet, and I go to Cisco, and I've got a maintenance contract with Cisco through their SmartNet. Or maybe Cisco does give free software updates, even if you don't pay for maintenance for certain security bugs. They'll give you a free one for that. So I download the fix for the router onto the TFTP server. I verify that I can ping the TFTP server for my router R1. Make sure there's sufficient disk space in the flash memory of the router itself. And then copy the reverse command, which is copy TFTP from the TFTP server to my flash. I would copy TFTP, flash, press enter. At that point, I will be prompted, what's the IP address of that TFTP server? What's the file name you wish to copy? What's the file name you wish it to appear on the flash memory of the device you're copying it to? And if it's a long file, it may take maybe a minute to copy. Okay, now I've got two iOS files on my R1. I've got the old one, and I've got the new one I want to test. Okay, this is kind of like dual boot on Windows machines. You guys ever installed like Linux on a Windows machine, and you could dual boot into Linux or Windows? Well, by default, the router is going to boot up the very first line in the directory command. Well, that's the old one. I want the new one. So what you do is you go into the router, go to the global configuration mode, and type the command boot system flash, and type the file name of the new file. And then you do a reload command, copy, run, start, do a reload command, and that'll now boot off the second line because you directly specified that, and it'll start using it. Now this licensing scheme, I'm not really fond of the Cisco licensing scheme because in the old days with this is like if you ever installed Microsoft Office and you got a key in that stupid 25-digit code, or you install Windows and you got a key in that code, well, most of the newer desktop and laptop machines have the code embedded in the motherboard. You don't have to type it in. With the old Novell network, we had to use licensed diskets to put features in. So there's a couple different ways that Cisco allows us to do this. We can get a license and use a Cisco License Manager that says License Manager. It's License Manager. It's a software product that you can use to manage all the licenses on your devices. And they also have a Cisco license portal that you can log into to get your licenses that you paid for. So show license UDI will show you this number, the UDI and the PAC number, and then you can type the command license install, and it'll put it on the computer, and then you reload, put it on your router, and then you can type reload command, and it'll start up again. So you can do it manually, but the Cisco License Manager product will do this automatically for you. You can maintain this on a GUI type device, and it'll keep track of this all for you. Once we got our licenses installed, or you just want to check, we can tap show version, show license. It'll show us this. Now, evaluation right to use. You want to try a feature set, you don't want to pay for it yet. You can type a command to accept a end-user agreement, and then you can license a technology package without paying for it, and you can evaluate it. You can actually evaluate it forever. Now, let's say you paid for a license on your router, and you're going to get rid of that router, and you're going to get a new router. Well, I can save that license file to another device, to like a server on the network. I can uninstall the license from the device and clear it out, and then when I get my new device in, I can get that same license I paid for and put it on the new device. Kind of convoluted in my judgment for this stuff. Okay, so we looked at Cisco Discovery Protocol and its brother Link Layer Discovery Protocol. We looked at Network Time Protocol for making everything synchronized so we can follow the bad guys as they jump through our system. We looked at the syslog feature because they vanish off the screen. We can save them on a file server with a cheap hard drive. And then we looked at our device management duties of backing up and restoring. Remember, the three most important duties of a system administrator are have a working backup, have a working backup, have a working backup. Because if you're not backed up and something goes wrong, you've lost company data, including that most important file in the entire company, the accounts receivable file. That means we can't bill our customers, and you better have your resume in effect, because you're going to take the blame. We talked about upgrading the iOS image and how to do boot system to change the new one if you want to try it Okay, let me see. Anybody else logged in? 1, 2, 3, 4, 5, 6, 7, 8, 10. I got everybody in there. 1, 2, 3, 4, 5, 6, 7. I got everybody on attendance. Okay, so hold on. I'm going to put this one screen back up here again, and just for the benefit of the people that weren't here at the very first moment, let's look at what's going on here for the next 2 weeks. Okay, there it is. All right. So today we covered Chapter 10. On Wednesday, I'm probably going to delete that 10.125 file and put another lab file in there. That's a little easier because I don't like that 10.125 file. It's really difficult to understand. Which is this cloud thing? Oh, you got the cloud thing is a router, and they don't tell you how to connect it. So I have another lab that's going to be better to use for that. I'll put that on there instead. So Wednesday we'll have a short sync session, and I'll show you how to drive the devices in the packet tracer and get started with that other lab. A week from today, a work day, there's no sync session on Blackboard. Please take the course feedback form sometime before the final exam day because Cisco has a business rule that requires that. I have also turned the practice final exam on, which has no effect on your grade, whether you take it or not, but you can use it as a study guide. Just answer any one question and say grade it, and it'll say, oh, you didn't answer the questions, and go ahead and submit it anyway, and then you can use the item, not course feedback, but item feedback. Click, you can see all the questions and answers. You normally can't see that. So a week from Wednesday is our final exam. If we were in the classroom, we'd report about 9:30 in the morning and take it. But the deans have asked us to keep it open all day long to give the remote students a chance to do that. So I'll turn it down probably closer to about 9 a.m. in the morning on that Wednesday, May the 6th. And you can take that exam anytime in the 24-hour period after that time. So the next day, Thursday morning, on May the 7th at 9 a.m., I'll turn off all the exams, and I'll have to compile. That'll be the final deadline for all work. That's the time where I have to compile all the grades and turn them into the dean, and I'm not allowed to be late on that. So get all your work done by that time. So you've got about 2 working weeks here to get everything done. If you're behind on any labs or chapter exams, chapter exams are 50% of your grade, including the final. And the labs, the 10 labs are the other 50% of your grade, and there's no skills laboratory examination for this course. Okay, guys, I'm going to unmute. I'll hang loose for a couple seconds in case I turn it on mute too fast. I'll put on mute and I'll hang loose for a few seconds in case any of you guys got any chat questions for me or anything, or the best way is really just to email me. Get caught up on those labs, get caught up on those chapter exams, and feel free to email me. I'm pretty obsessive compulsive with checking my email if you got any questions. Thanks for coming, and I've been enjoyed working with you guys this semester.